Morning. Chandra. Chandra. Hello.
Hello, sir.
Madam, Suhasini madam.
Yes, sir.
Shall we start?
Yes, sir.
Ramchandra, please give introduction about madam.
Yeah, okay, sir. Yeah, good morning to one and all. Miss S. Suhashni has been working as an assistant professor in the Department of Computer Science and Engineering at RMD Engineering College, Kavaraipatti, Tamil Nadu. She completed her BE Computer Science and Engineering at Welltech Engineering College, Chennai in the year of 2017, and ME Computer Science and Engineering at SSN College of Engineering, Chennai in the year of 2019. She is currently pursuing her PhD in the domain of speech processing at Anna University, Chennai. She has 2 years of experience in the teaching profession. She has handled courses for both UG and PG students. She also played a role as a junior research fellow in SSN College of Engineering for 1 year. Her area of interests includes machine learning, deep learning, natural language processing, speech processing, image processing, and wireless sensor network, etc. She has experience in working with internal and external funding projects. She has the lifetime member of ISTE and IFERP. Ma'am, welcome to the 6-day FDP program, ma'am.
Thank you, sir. Thank you for the introduction. Good morning, everyone. First of all, I just want to thank the institution as well as Kiran sir for giving me this opportunity to give a lecture on this FTP. So I hope it was already the 3 days has been completed, and now I'm into my 4th day, right? So I'll be sharing my screen. Just to confirm me that whether my screen is visible.
Okay.
Is it visible, sir?
Yes, ma'am.
Yes. So what I am going to talk about today is the generative artificial intelligence. So I'll just talk how what is generative artificial intelligence and how it is how it is being used, and in whatever fields and whatever domains it has been used. All such things I'll be discussing with some deep insights of how it is used in speech processing. So coming to this general artificial, I'll just give some introduction about artificial intelligence. We know this artificial intelligence is playing a major role in nowadays in the technology. So inside the artificial intelligence, we have machine learning, deep learning, and all those things. Making everything automated by with the predictions, everything is in these real time life is going with all the predictions, and how those prediction is going to happen with this generative artificial intelligence. We'll just see it. So first is we know artificial intelligence, just we are going to predict something. So but this generative AI is something different about apart from that predictions. What this generative artificial intelligence will do is it will generate, as the word itself says, generate. So it is going to generate some output. It is going to give some output. We can say that it is predicting something, that is also an output. But I am also telling that it is not going to make any predictions. Apart from that, it is going to do something, right? So it is going to give some output, but it's not as same as like predictions. So what is that then? That output is, it is like a data. Okay, so a data is going to be produced. So how this data is going to produced? So we are having some set of data, right? So you're going to predict something, you're going to output something. So artificial intelligence is going to predict some output based on the previous data. So we need some previous data, and in suppose some, in most of the cases, we are not more than enough having the data, okay, not enough data to train your model and to make an accurate predictions. Only to until now you can day by day each and every algorithms has been introduced to in order to improve the performances, in order to improve the uh, accuracy, all those things. So to increase accuracy and to increase the performance and the predictions levels to be high, you need more amount of data. When you increase your data, so your predictions will, so the machine the model will get trained, so trained based on the training, and it will give a increased performance, all the such cases. So this generative AI is going to output your data, which means you it will create some new content, okay. It is going to create some new data, it is going to create some new data and add to your data, I mean a data set. That is for that purpose we go for this generative AI systems. So what is the data? Either it is an information, which means a text data, not only a text data, it is also an image data, it is text data, it is audio data, depends, though, depends upon your data set. It is going to create some contents, okay. So as I'm telling that it is going to create some data, new database, the model itself is going to create some data set. No, data is nothing, it is not only the text, it includes images, audio, and everything. So this is how generative AI, which is different from a normal AI. Normal AI is going to predict something based on the data what you create. This generative AI is introduced to create new data itself, okay. That data will also be created with the help of the model, okay, whatever model we have created. So coming to some of the key terms which we have to know in this generative AI or AI systems is, I'll discuss in the slides. So first, as I said, this generative will model will learn and generate new data samples, okay. So it will create some new data samples and it will get added to the existing data sets. So how it creates that new data set? By learning the patterns and structures of the data, it learns the features and it produces the new set of samples, okay. Based on the based on the same distribution, how the other data set, if I have some set of sets, like from I have some hundreds of data set, but it is not more than enough to train my I mean model. So I want some more data set, so I want to create some samples. I cannot take from anywhere, or I cannot fake it. So I want the model itself to I want the model itself to generate the new data based on the same patterns and structures with the same set of distribution. For that, I'll be going for this generative model. So generative model is something different, and now you need some discriminative model also as well. So what this discriminative model will do? This discriminative model will focuses on modeling the the modeling the the structure of how a model should trained to develop those samples. So it is like, it is not the generative model, it is something opposite to the generative model. So it will not create any sample, rather it will create some different boundaries and different classes, so that you can categorize your data. So you are creating some new data, right? So that has to be categorized in different classes, or in different surfaces where you want. So you have to fix some boundaries and fix some condition. For that, you want some discriminative model. So this discriminative model will either classify or it will label your data, okay. So labeling is nothing but you're naming your particular data. So I am generating, okay. So I have a set of, for example, I'm taking a data set with a fruits. If I take a fruits data set, it is not like every time you will have a apple data set. It is not that every all the fruits are apple or mango. So it is a combination of apple, mango, banana, orange, all those things, right? So when I create with the help of that previous data only, this generative model is going to generate generate some new data samples. So similarly, this discriminative model is going to create a model which will label or classify this is whatever the new data arrives. This comes inside apple. This comes inside orange. So similarly, I have to label also. Some cases depends upon the situation and the problem statement. You will be changing your metrics, either classification or labeling. So based on that, the label is nothing but I'm labeling after the new sample generated by the generative model. This discriminator model either classify or it will label with the names. So this is how these two will work. And next is generative adversarial network. So this generative adversarial network is a kind of algorithm. So it is going to work with the help of this generative AI concept. So how it's a kind of neural network, right? So this generative model has two neural networks. One is generator and the discriminator. So these two will do, this generator will create some new samples, while the discriminator will distinguish whether it is a real sample or generator sample. We should know whether if I'm giving some input to the system should understand or should learn that it is original data. It is the data which is all directly collected from that place, or it is generated by the model. Those things will be identified by with the help of this GAN network. So if this GAN network will be worked when you combine both generator and the discriminator only, so that it will give some quality generated samples. Okay, the quality of the samples will be increased. So next is coming to latent space. Why we want this latent space? Why I'm talking about this latent space? Latent space is like where we use this latent spaces if I have some less number of features for particular data set. Okay, the most common data set which everyone knows is iris data set, where only 4 features will be there in the data set. So that comes under the latent space. So what is latent spaces? It is a lower dimensional representation learned by the generative model, which means I am going to generate some new samples. So that new will be generated by learning the previous features, right? So for learning the previous features, you need some more features. You should now coming to this latent space and all, it will have only lower dimension. So the lesser number of features. So that has to also to be handled, and that has also to be increased with the help of this generative AI. Next is So next is one I talked about this general adversarial network, and the next is variation autoencoders. Everyone knows what is autoencoder. With the help of encoder and decoder concept, we'll be attaining this auto encoding part. So variation autoencoders which will map the input data. Okay, it will also have the same encoder and decode. So this encoder network, what it will map is it will go and map the data which is with the latent space. Okay, so it will map the input data to the latent space, to the lower dimensionality. Whatever the data you have, you will go and map it to the lower dimensional representation, and based on these encoding part will do with the lower dimensional. So next, in the decoding part only, you will be generating the new output points in the latent space. So you will be like including that old data to the new data well, in the encoding part. This encoding part will read all these features and everything, and it will be sent to the decoder, and that will generate the new set of output points in the latent space. So which will also increase, okay, where you will just train this variation autoencoders will be trained with a maximum likelihood by using, so maximum likelihood, and taking the maximum likelihood and training them only will be with the help of the original data, so that the generated new samples will be learned distribution. Okay, we'll have a normal distribution, which means learned distribution is nothing but all the data, all the representations, everything will be learned by your model, so that you can get some accuracy. These things are like why we are training these more with more number of data and everything is like to get a improved performance and to get a good accuracy, so that this automation is having some I mean some usefulness, right? So next is auto-regressive. Auto-regressive is like this is only for generating a sequence of text. This auto-regressive model will just go for this text, like for example, this next word prediction is a common thing which we know all those things, right? So the only we have some set of words, based on the some set of words it could be another set of words, because we have some, if I take some here, we have different types of here. If we have some are, then is, was, all these things are there, it will learn, will make the system to learn the data text with the help of this auto regressive model. So for the text only, particular only for the text it is going to handle, you can go for this auto regressive model. So those who are working in the NLP and those who are going for text processing, all people can go for auto regressive model to increase their samples, so that they will generate the text sequence of text where the model can predict the next word based on the previous word in sequence. So this is how this auto regressive model used. So we have seen this next word prediction concept in many real time places, like if you write your email also, you'll get some predictions, right? Nowadays in WhatsApp also we are getting that if we type good, it is automatically showing the next word as good morning. If when I go and type then it is coming like good and then coming morning. Then if I type good and it is coming as good evening. So nowadays in all the applications, in every application, wherever we are more you, where the usage of the text is more there, and all this next word prediction has arrived. So next, coming to this deep fake. Deep fake is nothing but we are generating. So we are generating our model. So we have to also classify, and we should know which is the original data. So it should not be same. It is not same, right? So why here is, though you just create new data by training your older features and all, there will be difference when you train with the original data, and then will be a difference when you train your model with your generated samples. So for that, to make it a classification, you need some real data and fake data that has to be classified, right? So for that purpose, this deep fake technology has arrived. So this will identify the highly realistic fake content, okay, so that you cannot always, it cannot be misused, right? So some places what they'll use, anyhow it is generating something, so why I want to go and search for all the original data. Also, most probably when you go for this medical images and all, it is not that much easy to collect the medical images, but instead some of the images are available in in your online free, through Kaggle or through GitHub and all those places you are provided with these medical images. So people can utilize that, and they can increase your data, increase the data set with this generative model, and they can, they can provide that this is our own data set which has been created by ourselves, which has been created by us. So those things cannot should not be misused, right? In for that cases, to evaluate your data set, if you have a deep fake methodology, they can easily identify your real data and fake data. So next, coming to this conditional generation. Conditional generation is also going to create some new samples with the help of the conditions, okay, not with the help of not by reading the features alone. So before whatever I was talking is generally it will create some which means it is going to create some samples, right? So based on reading all the features, I'm not just giving some particular thing. Should learn only four things. You should learn only three features, and you should learn only from horizontally. You have to learn only five data. So all these conditions I'm not giving. In some cases, if I want only with that type of conditions, then I can go. I need some that kind of model also. No, for that kind of model, I will go for this conditional generation. So based on some conditions, if you are going to generate the new samples, then you can go for conditional generation. If you don't want any condition, if you want a simple a new samples, whatever it is collected before, then you can go for another different types of variation autoencoders or simply generator model. All these things you can go. So inference is nothing but a general. Okay, this is a general model to create your new sample with the help of this generative concept. So this is the structure of generative adversarial network architecture. So initially I'm having some random vector, which means a random input. So I want that input to be passed to the generative model, and I want some new data. Okay. So what it will do is, see, I have random vector. So this random vector is being passed to this generative model. So this generative model is giving some generated fake example, which is a new example. So next I'm going to give this to discriminative model. So this discriminative model will have the real example and the generative fake example. Based on that, it is going to, it is going to do some binary classification. But if one input is going to come, then that will just do as I told, no. So this discriminative model will not, it will not create any samples. Instead, it will classify. Instead, it will classify or label. Now, what is it is doing is it is doing some binary classification, which means either whatever data is coming through the discriminative model, it has to classify whether it is a original data or a generative data. So this whole example you can just go and check for this. Either it is real data or identification of fake data that has been done. So once it is classified, that will be updated to generative model and the discriminative model as well. Okay, so this is how the generative adversarial network. So the main concept two places is generative. So if this architecture wants to run, you not only need the generative model, you also need the discriminative model also. So for that I'm just giving some input, and generative model, it will generate, it will learn all the features, it will send to these generated fake examples will be generated, and that will not directly go to the binary classification. Instead, it will go to the discriminative model. The discriminative model is also provided with the real examples also, and then some binary classification. Then you're just creating either it is a real or a fake. Now we have some set of how this generative AI works. We have some 5 steps as always. Every model follows this. We have some data collection and pre-processing. So you have to collect your data. So not without any data, this generative AI is not. Don't misunderstand that it will generate data means it will not directly generate data. Only if you have some basic data set, it will generate the data. So you have to collect some data set. Without data set, you cannot do generative AI. So that content can be an image, text, audio, and any other form of data, which I already mentioned in the previous slide. So the pre-processing will also should happen, which means if I take some images, so the unwanted noise will get reduced. If the text is there, then unwanted symbols will be reduced. If audio is there, the silence. Okay, while recording the audios, some people will have some will take some pause, so there will be a silence in their in the recording. So those silence they will be removing, and they will do some sampling rate reduction also. So those things will be handled in audio, text, and also unwanted symbols will be there. That will take some place. So, and because in some places one question, one word will act as a question. Some in some places one word will act as an answer. So these things are there, no? So but I don't want in such cases. So for that they will probably avoid some, some symbols and images, this unwanted noise, and size of the images, resizing it and everything. Or if you want to do some segmentation, all these process will be handled in the this it will be done handled and done in the pre-processing step. So your first step is going to be the data collection and the pre-processing. Next is you're going to train your model. So we are going to train your model. The training will take place only with the data set which has done is pre-processing. So the pre-processed data will be given to the generative model for training. Okay, now the choice of model. Okay, now you have to select some model, right? I've discussed already. So generative adversarial network, variation, auto encoder, auto regressive models, all those things. So now I want to identify the type of data and the desired output also. So before picking into the model generate training, I want to understand the different types of models. So that's why I've just gave in short introduction about each and every model in the previous slide itself. Now I just want to handle the I want some prediction of text. I'm giving some image and I want the what is that image. So it is going to handle both text and image. So if I go for auto regressive model, I want only text. So now so that I can go for this generative sorry, auto regressive model. We know that auto regressive model will handle some text. It will generate the text in sequence. So if suppose I'm going for this problem statement, if I go for auto regressive model, is it not, it is possible, but it is not possible as well. Why? Because I'm giving some in my input as image. Okay, it has to handle the image as well, right? So then I want to choose a common model, which either it can be generator adversarial model or variation autoencoders. Okay, so that I can go for that. If suppose I just want to, and I'll give another real time example. So we know nowadays one of the recent, now in text processing, some problem statements are arriving. What is it? Is the identification of depression. So identification of depression in social medias. So nowadays everybody we are sharing in status, putting some post in the Twitter, WhatsApp, and all other Facebook and all other social medias, right? Now people started to identifying the depression state of that particular of each and every individual by their status itself. Now for that particular for identification of the depression with the help of the status is only is going to happen with the help of the text. So they'll take what post they are putting, what is the words they are passing it. So now I'm going to handle everything in the text. So I'm going to take the message what they have posted, and I'm going to tell they are in this in what level of depression. So both is text. Okay, my input also is text, my output is also text. Now I can go for this auto regressive model. Okay, similarly you will have some for to handle only the images. You can go for generative adversarial network, variation autoencoders, or if you want to go, if I want to handle my speech recognition also, I can go for this variation autoencoder. So likewise you have to pick the model. So to pick the model you have to be very much clear about what type of data you want you have, which means you should be very clear of what input you are going to give and what output you are going to get. So only then you can select an appropriate generative models for your system. So during training, the model learns, okay, how the model will get learns about the patterns and structures of the data, what you're providing, and it will create some, some distribution about the data, and it will generate, right? So all these training samples will be given to the model to get for training purpose. Next is latent space representation. So this generation learns the latent space representation, which is a lower dimensional representative, which means a less number of features that so it will capture that so this lower dimensional means less number of features will be captured, and the variations of the data will be analyzed, and it will be easily manipulated as it has some less number of features. The manipulation is very easy, and the generation of new samples also is easy. But when going for the how good it is, how good that particular data is, like something less, will be less because we have some less number of features, right? So but it will create some the creation will be easy, so you have only less, the timing and the learning process will be less as we have less number of features, which means the pattern learning or the structure learning will be reduced, so it is easy to manipulation and the generation of new samples. Next, coming to the generative process, generation process. So now my model is I've just collected data, I pre-process and sent my data. I selected my model, I given some model training to the model, and I create some represent. I'm done with the manipulation of the features, and now I want the generation process. Now in this generation process, my model will be trained. Now I will get the new content with some sampling. So what now I have some uh, so in the GN we have two places here. One is with the help of GAN. So the generator network generates a new sample. How this will be generated based on the random noise, and with this pumps sometimes you can give some with specific inputs as you have. Don't want to read the entire image, only with this portion you can read, and you can generate the boundaries can be similar. If I want to detect some hole in for medical image, if I'm taking, if I want, or else everybody is very much aware of that leaf detection. I want my leaf that some diseases will be in the stem alone or in the center of the place alone. So I want to display one. I want to identify that only. For identification, that I want more samples. For that, I'm creating samples. So my data, my generation of new samples can only concentrate on the whole, not the entire leaf, so that I can fix some condition to select only in that particular boundary. The rest of the things can be as similar as same for the other new generated part also. Only the particular boundary what I have fixed only can be changed, and new samples can be generated. In those cases, you can go for this GAN. And coming to this variation autoencoder also, the sampling points can be increased for this encoding and decoding part. So next, coming to this evolution and refinement, this evolution and refinement is based on how the various depends upon, okay, one will measure how efficiently it is working, one will go with accuracy only, one will find with FN score. So this evaluation is depends upon the the person who is going to calculate or model. Some will like some will use some pre-trained models, and they'll give some their own data set, and they'll measure the output. So how efficiently our data set is working for this particular model, how efficiently it is working for their own data set and their own model. So for likewise you have to measure it. So all these measurements and evaluation will be coming in the last step, and the refinement is nothing but the fine tuning process. I told some pre-trained model if I'm going to use. It is not always that I should use only pre-trained model, not like that, right? I can just change the pre-trained model by training with my own data set, and that particular part is called as fine tuning. I mean training your you're training your the model with your own data set, with where the model is already available, but I'm just giving my own data set and training the system so that it will be fine tuned. Okay, so once it is fine tuned, it can give a better result than you are using with a pre-trained model. So to improve the quality also. Okay, so next is coming to this. Next I'm just going to talk like where it is used, and what are the applications has been evolved in these different domains. Okay, so the major domains what people are working is text generation, image processing, speech, and some augmentation processes. So I have some text generation first. So based on the, you are going to generate new text based on the patterns from the existing text data. For that, to for the text, I told already it is auto regressive models will be used, and apart from that you have RNN, recurrent neural network, and nowadays they have used some BERT transformer models also. BERT model has arrived as a transformer model. So with the help of the transformer model also you can go for that. So this text generation has been the I mean the top thing which has been going now in recent days, like once the chat GPT bot everything came, right? So it is that whatever we ask it is generating some text. So my input is text, my output is text, so it is full of text. So chat box, chat GPT, you are very familiar with, everybody would have heard about this chat GPT, which is giving a different output for a single question. So all these things, these being the auto generator. With the help of this auto generator way only, it is also working in the artificial intelligence. Next, coming to this image generation is also like some you have some examples, okay, real world examples in your uh, day-to-day life. So from that, if you want to create some new images with the help of variation autoencoders with the help of GAN, you can just, it is possible. So for this image generation also, this data augmentation is is possible. So what is the data augmentation? I'll let you know in the forthcoming slides. So this, with the help of this data augmentation, if you use data augmentation, it is proved that the performance of the machine learning model is also increasing as well. So the images has been increased, so that the accuracy is also increased. So the applications here are the DAL E, which means for realistic images, to get the realistic images of the different things, and Mid Journey. These two platforms are the very interesting and popular, I mean, platforms to provide you with the realistic images for image generation techniques. You can go check with that. And coming to this video and speech generation. So video and speech generation is, so what we'll use. So I have, it is video means, do we are going to handle is it is as a video? No, not like that at all. So the video will just being splitted into frames, and the frames will act as an images. So videos also being I mean going to be create some frames, and that frames, you can say how a video can be I mean generated in samples. So we are not always going to take the input as a video. The video will be divided into frames. With the help of the frame matching, you are going to create the other frames. Okay, so what is the common thing? Frame places. Okay, the pixel size, and the all these things will be mapped and will be generated also. So you, for that you have to identify some before going into video generation, they'll have to fix the fields also, because gender fields means, for example, mm, a different I mean a different places you can go and check the videos, right? Take the videos, right? For example, if I take my video input is my a news reader. Okay, somebody is reading the news, and that is the video, and which is the input. If I want to resample it, if I want to create new samples, would I want to cover all the frames? Not at all, right? Only the person who is there, because other things will be a static. Only the person who is reading the news will have some dynamic actions, right? So in that cases, you don't want to take all the frames. Whereas when you just go and take some sports, entertainment, driving, all these cases, no, there will be, fast movement, slow movement, all these things will happen. So for that, you have to identify the field. So based on the field, you can go and do the, I mean, the creation of generate the news samples. Okay, so these when you go for the sports and entertainment, you need some more attention also. The speed also you should calculate, because the entertainment, the movie speed and the sports video speed, speed will be different. The movie will be in some phase, but the sports is not like that. When you take football, it will be like running somewhere. But when you go for cricket, the speed of the video will be something. I mean, the action of the person inside the video will be less, right? So so what the next frame can be different. So when I take football, the person, if I take the analysis and split the frame in the seconds, in the second frame itself, the person will be moved to the next side. When coming to this. I mean, the some other sports activities, that is not that much speed they will not run. It is not the running race. They'll be stand in one place and they'll be I mean playing. Okay, so carom board, all these things are there, no. So you have to identify the fields first. So next, coming to the speech generation. Speech generation is, we know the input is going to be the speech audio signal, and your output is going to be the text, and not always that is a speech recognition, that is a speech generation. Sometimes it can be a text, and that can be given to the speech as well. Okay, so it is when you say it is a speech recognition, then that is speech to text. When you say it is speech generation, then we can say it as text to speech. So next is application. So some of the applications are deep brain, speech brain, synthesia utilizes. All these are the available, I mean, platforms for handle the speech. So now I'll just give some deep insight in the automatic speech recognition. So automatic speech recognition. What is automatic speech recognition? Automatic speech recognition is like when you give some input and I'll get some output. So automatically it reads. If I'm going to talk in front of some, I'm going to design some ASR model. If I'm going to talk to that model, that will parallelly generate some text without. I mean, the model is already trained with some data, but automatic. What is automatic here? If I speak on spot, if I'm just clicking my record, so it will just on the parallelly it will just create some text. So this is automatic speech recognition system. How then this ASR will be designed is with these two types they'll design. Okay, one is speaker independent and the other one is speaker independent, which is like in some places only one person will be talking, right? If I want to daily, I'm just improving my place. Okay, I'm just entering into my house, or entering into my app. For a best example, I can go for this laptop. Okay, so I want to open my laptop with a voice recognition password. So the user is only one user. So this system is going to open this laptop with the help of only one user, which means it is speaker dependent. So only with the help of only one speaker information, I mean one speaker data. Okay, one speaker's features alone, it will just get trained, and some automatic speech recognition on works. If suppose it is not only one word, if I take they are going to be a public place. Okay, in public places, if I want to book a ticket and someone many people will come, ticket give a ticket from this place to this place, automatically gives. It is not user specific, many user, n number of users will come. In that cases, you have to design one model with a speaker independent also well. Okay, so this is the architecture of the ASR. So first I'll be giving this voice. So this voice is being given to the sounds analysis. So you'll just all the sound, the phoneme sound, all these sounds will be just recorded. And now the acoustic models, all the acoustic models, the phoneme conversions, all those things. It is not that whatever you are talking, I'm talking it as like rat, ra. The representation is different. Okay, so those things will be converted from the acoustic model, and that will be given to their speech recognition decoder, and the language model is separately is there. So if this sound is there, what is the next sound to be combined and the and it will be given to the text. Okay, to the so the language model is a major part here. So this will give what is the input. So your input is voice, some sound analysis is done, and that is given to the speech recognition. The acoustic model will recognize, will understand that what has been given from the sound analysis, and it will create some acoustic noise. And from the language model, it will identify what type of word it is, what is the next word, all these things it will be it will be learned from the language model, and finally that will be and the text will be generated. So this is how the architecture of ASR works. And next is I told about the acoustic and language model. So the representation of the sound that make a word, so the sound, it will these only the sound ta pa, those things will be represented different in, so that will be learned by the acoustic model. So the words itself, what are the words will sound similar, what can be matched, what can be matched in sequence, all those things will be mapped with the help of language model. So next, coming to this ASR, how ASR works. So I have audio. This audio will also be split it into frame. The frames will handle the acoustic frame. So from the frame to the state, here I'll be just dividing into some acoustic model all here. So from here, the phoneme conversion, which means the ta sound, the sound will be changed here. The sound will be changed as a text, and the text will be combined together, and it will form a word, and that form a word will be represented as a sentence, and finally it will give some meaning. So these conversion of audio from frame state to phoneme will be an acoustic model, and and the word sentence meaning will come under the language model. So this decision these are the feature extraction. So it is here feature extractions here. So why it is decision tree here is the decision tree here is why. Yes, I want to decide. Yes, I want to decide the phoneme. Once it is just converted from sound to phoneme representation, I want to know what can be the next possible sound as an output. So I want to know the sound as also. So for that, I'm just giving here. So these are some with the help of decision tree. So language model, obviously, it will work with the help of NLP concepts, right? So next, coming upon to the steps we have in speech recognition. First, we'll just convert from analog to digital conversion with the help of and quantization, all these sampling and quantization techniques. And you have to do some, obviously all the data will have some pre-processing step. Here, what are the pre-processing step? Previously I told, no, some long period of quiet, and also we have some noise in the in in audios also, that also has to be handled and improved. So the removal of when it is here in this diagram itself, I told the audios will be converted into frames. If suppose some frames are having a silence, okay, some frames are having only a silence, so the removal of silent frames will also happen in the speech processing step only, pre-processing step only. Next is what are the features you will be extract, and that will be converted to phoneme or syllabi. So these features will be extracted as a state. From the state, you will be just converting it to phoneme and syllabi. Next, after that, a word selection. So once it is the phonemes are combined and giving some word, and based on the words, you will just combine the sentence, and you will get a meaningful sentence as a text as an output. So automatic ASR will work as a speech to text processing. So inside, okay, inside this automatic switch processing, we have a concept of code switching that also to be addressed, which is very important in for our recent days. Which means, so we are like people are not knowing how to type, how to study, all those things they are not, where they were not aware of it. For those people, if they want to book a ticket or they want to get something in from the vending machine, or they want to get something with the help of, without knowing without the, if the uneducated people want to do all these things, they can speak, right? They will speak on their own, which means we cannot fix it when we speak it. No, they are not going to speak a constant language, right? They'll have some mixture of languages, which means if I take Tamil, they'll combine the Tamil and English. If I take some Telugu, they'll use some Telugu and English. If I take Hindi, Hindi and English, they'll combine and speak. In that case, our speech recognition system should also handle. I trained my ASR system with if I'm going to provide some mission in in north side, then if I cannot say that only the people will speak only in Hindi. No, some cases everybody is using some English words. So that has also to be trained by your system. For that purpose only we go for this code switching. So your ASR model will address the code switching. If the person is going to switch from one language to another language, that also should be handled, and the exact meaning of that code switched place should also be recognized by the system, and you have to get the exact output. Okay, so however there are different types of code switching also. So one is tag switching, word switching, intersentential switching, intrasentential switching. All these switchings are here. So tag switching is like when you are going to switch your language from one place. You're switching your languages, right, from one language to other language. If you're going to make that switch in at the end of the sentence, that is tag switching. That too, if you are making to make a question mark. Next is intra-word switching. A word within a word itself, somebody will make a switch. So that is called intra-word. And if it is going to happen in the end of the clause or in the end of the sentence without questioning, then it is intersentential switching. And if it is going to happen within a clause or sentence, not at the last, then it is called intrasentential switching. So next is coming to the speech brain toolkit. Okay, so speech, I told them one of the applications in speech recognition, which comes under the part of AI also. It is an open source toolkit only. You can go and look into it. There it has been in a few years back it came to handle a speech system. So you can train this. It is as though it is told. It is said as toolkit. It is all. It use a model, right? You can remodify, you can fine tune that model with your own data set. It is fine tuned with English, right? So you can also remodify with your own language, and you can use it. So this is the general structure of the speech brain. So how you will give your data set is, you can either go with your PHP or JSON. This process is going to work with the help of hyperparameters. You are going to design the hyperparameters. So with the help of the hyperparameters only, you are going to train. So how many data you want to handle and how many things you want to handle, all those things you are going to just tell, and you are going to make it. Okay. So next, based on these things, this is the way training script. This is a part of training script where you should uh, change, fine tune your module according to your system. Okay. Next, coming to this brain dot fit, you will just this is a model. This particular training script will be just given to the brain dot fit model, where all your data sets will be trained, and it will be created as a new model, and that will be fitted in as a brain dot fit, which is the model, which is the fine tuned model. This a particular image describes about the model which is existing. This is not a fine tuned model. This is the original model's representation. So next is the just the structure of how they'll do, as we always take the I mean first is the pre-processing. This is an audio sample. Here you'll do all the pre-processing, time drop down, frequency drop down, speed change if you want to do noise symbol, revibration, all these pre-processing steps will happen. Next is what features you want to do, whether you want to do attain MFCC features or the spectrogram features, all those things. Then coming to this speech recognition, either you want to use transformers, encoder, decoder part, all these things you can discuss. This will attain all these things. And finally, some beam search processing is being arrived for which combines this beam processing is like this will handle only the this is going to handle only the audio. But you need the language model to get a better accuracy, right? You without language model also you will get the output, but if you include the language model, your accuracy and your predictions of your text will be and higher. Not a a simple difference is will be a huge difference. So you can always go with the language model. With the help of language model, you can give the prediction. So this is how the speech recognition works. Automatic speech recognition, which means then how the prediction is made through with the help of AI, and next and with the speech brain platform. So you want to prepare data and you want to so here we have tokenizer step. So where you will make your data into tokens and you will map with the language model, and these two things will be combined and given to the recognition, and finally the model predicts the output. So next is the final thing is your data augmentation. Your data augmentation is nothing but if I have a sample image, most probably this data augmentation will be for the images. How it will generate new samples is they'll do some flipping of your image, cropping the image, rotating the image, changing. With these features changes, they'll create some. So four images will be cropped. The four images will be rotated horizontally, vertically, top, bottom, all those things. With the help of this, they'll be just creating it. Why we go for this image here? When you do that, this overfitting will can also be avoided. So here some of the application synthesis of AI platforms and all those things. So with this techniques, you can just do I just covered all the domains so that persons who are working text, speech, and image processing and all those things can utilize it. So thank you. Any doubts? So I'm done. Karan sir, I'm done with my part, sir.
Hello. Ma'am, thank you, ma'am.
Thank you so much, sir.
Participants, if you have any doubts, can raise your hands. I will unmute you. Okay, ma'am. I think there is no doubts.
Yes, sir. Thank you,
Okay,
sir.
ma'am. Thank you,
Thank you so
ma'am.
much.
Thank you for your
Thank you,
valuable speech.
sir. Thank you so much, sir.
All the participants, the feedback link is posted in chat box. All of you fill it.
So all the participants, please fill the feedback form. It is posted in the chat box of YouTube and Zoom. Those who have filled the feedback form can leave now. Thank you. Tomorrow session will start at 10 a.m. All the participants, please fill the feedback form, which is posted in the chat box of Zoom as well as in the YouTube. Previous day feedbacks will not be given again once it is closed. So those who have filled the feedback forms can leave now. Thank you.